Hello, on this occasion we will present the EmergencyCAD program, which is part of the package Water Systems. To start our tutorial for today, we will click on the Water and Sanitation Design icon to run the package and then click on Execute button to the EmergencyCAD program. After running the program, we can see at the right side a schema that represents the pumping system, a storage tank, a tank tap kit for water distribution, and the population to serve. In the first table above, we must enter the project data, such as the name. We're going to enter example 3. Then we have to enter the length of the pumping pipeline. Let's assume that we have 300 meters. By default, we are having an elevation in meters of 100 at the water source attachment point. Leave it so. We also have to enter what is the elevation of the distribution tank, for which we will have to assume 120 meters. And finally, suppose that we have a population of 1,200 people. With this, we have finished to entering the data. Then we can notice that our data will be displayed on the drawing. By doing click on to Calculate button, the program will provide the first design data. We can see in the table below that the flow has been calculated. In our case, this is 124.8 liters per minute. Please notice that the flow is presented in liters per minute units, responding to the same way in which the manufacturers use to present the curves of pumping as part of the technical specification of the equipment. Also, the program has computed the diameter as part of the design using the criterion of economic diameter. The head loss due to the calculated flow and the stipulated length and computed pipe diameter is also considered to define the age of pumping. In our case, we have 20 meters plus 2.34 meters of head loss. Then, this is 22.34 meters of pumping height. To choose the type of pump, the program provides this table where we can see that we have not only the pump specifications but also the pumping curves graphs, which will be very helpful to choose the most appropriate pump to respond to the demand and flow. For example, using this pump for a flow of 125 liters per minute, more or less, we have a pumping height greater than 30 meters, which is greater than our required head of 22.34 meters, which means that this pump could fill our needs. Even if there are other pumps which can also meet these requirements, they are more powerful and therefore more expensive, reason why we use the criteria of economy by choosing a pump that technically fits what we need, but that is also the cheapest. In our case, we can say that the first one fills our requirements, both technical and economical. Once we have decided on a kind of pump, we double-click on the row that contains its information. We can notice that the table shows the specifications of the pump and the quantity of units that we need to supply this project, which in our case is 1. We can have other cases where we may need more than one water pump due to higher height of pumping, in which case we can install several pumps in series, or other cases where the flow is such that we can that we have to install several pumps in parallel. Once you have chosen the pump, the program will display another table where we must choose the storage to respond to the theoretical storage volume, which in our case is 30 cubic meters according to the first estimation. In the table, we have different type of bladder tanks, a tank type Oxfam and a tank of polyethylene. To fill the required volume, we will choose 2 tanks of 15 cubic meters, since this will allow us to have a reserve tank when we are cleaning or servicing any of the tanks or even giving the necessary treatment. Remember that this is an emergency project where we will probably have to use aluminum silicate for the sedimentation of the suspended solids, or other chemicals such as chlorine for disinfection. In both cases, we need to have a contact to ensure the effectiveness of the water treatment. Let's choose the tank type bladder of 15 cubic meters by clicking in this row. The actual storage is 30. Reason why the program will choose 2 units of this kind of tanks. The estimated pumping time is 4 hours and we will need a stand tap kit of 6 taps. In terms of calculation, that's it. You can now save the project. We can also print out the results by clicking this button. Something interesting about the use of this program is that the data can be stored indicating the pumping equipment and storage tanks available either in our warehouses or in the local market. This has been everything for now. Thank you for your attention and until next time.